we found, first of all, it was really hard to actually get like the cylinder to like the top. Like there was always kind of like air, so we flipped it over, like water would come out. But we kind of estimated how much water we lost and then subtracted that from the number that we got. And our average was about 40 or 54 milliliters. We only did 5 trials, so it's not like a big pool of data, I guess. So yeah.
Okay, so our group, me, Kate, and Jane, we so in our experiment we got like pretty different average than this group. We got 81 milliliters, and all of our like thing. We also before, like at the beginning, we kept like doing it at 250 instead of all the way up to the top. So it was like kind of like different. We had to redo some of our data points, and then we got 81.
A question for you guys: did you guys fill it all the way to the top?
We tried to,
yeah.
Oh, so for ours, we were able to do 3 trials. We averaged at about 96 milliliters, not really more, 97, 98 milliliters. And then for all 3 of them, the difference was 0.6 grams, giving us a density of about 0.006 grams per milliliter. So yeah.
Did you guys also fill it all the way to the top?
No, we did not. We just saw where it started and then where it finished, and then we just found the difference. So the total
So we actually had kind of like an interesting path. So at first we were using the really big beakers that we only felt like well, we saw that a lot of the other groups were getting like the air was like 100 milliliters about, but ours was like 25, and so we were really confused. But then we found, like, once we started using a smaller beaker, that we think it actually might be the air's ability, like the carbon dioxide that the Alka-Seltzer releases, like it's like pushing the beaker up, right?
Yeah.
And we didn't think the water could do that.
Because of the heavier beaker, like maybe it wasn't able to like push the water down through the bottom of the beaker.
Yeah, so then like the water couldn't release and the air couldn't like fill as much space. So once we started, so that's why we only did 2 trials, because we were really confused about that. We thought we must be doing something wrong. But once we used the smaller beaker, we got 2 data points. And we don't really feel like we have enough data to conclude that like what the density is, like Sam. But we did find a density on what our average was on like the average between these, and it was about 0.01 grams over milliliters.
We also had the same problems then. We started with a big cylinder, and we couldn't really tell the difference because it was so low. We switched to a smaller one.
And we also used then half a tablet, so it would like go into the smaller one.
But we only got 1 data point, so we did write down the density, but it's probably not accurate because we only did 1 data point.
We got like 0.0012 grams per milliliters, and like our particle diagram, like we think that like the Alka-Seltzer goes in and the water like goes out, and like Cody, you think that like the bigger one wasn't, like the water couldn't go out of it because it was too heavy. So yeah.
For ours, we got 5 trials done, but most
for the volume.
for the, yeah, but a lot of it's kind of weird because we don't have the density. We have the mass of 3 of the trials because we did some stuff out of order.
But we just don't feel like
yeah.
we can like
include the density because we have such little trials.
Yeah, even if we calculate the density of what we do have, we also think that trials we have are pretty inaccurate because when we were trying to actually, they get the tip of the, I can't talk today, the water thing, we ended up spilling a bunch of water, and we think that actually really affected it because some of our points have they have a really high volume and others have really low, and they're not most of them aren't even nearly in the same ballpark. The only ones that are close-ish to each other are trials 2 and 4. We both got 50, and so we don't have a claim, we just have questions, which are why do we have such inconsistent information, which, like I said, is probably because of spilling a bunch of water, and also did the losing the water affect this? And then we also did a particle diagram, which is the Alka-Seltzer tablet before, where it's supposed to look like a solid mass, and then when it's just kind of spread out after. And so yeah, that's what we have.
Adding on to Dylan, our group at first, what Lucy was saying before, we did 250 milliliters, and at first we were getting really inconsistent data. Like one point it dropped 20 milliliters, but then later it dropped like 120. So I was just wondering if some groups filled it all the way to the top, but like Sam's group, they didn't fill it all the way to the top. And I was wondering if you guys thought that affected the data in any way.
I think so.
Well, it's kind of the reason that we decided to do it is because it takes into account the fact that you might spill water when you tip it over. So you're measuring it all while it's upside down in the water, meaning that you're not going to spill any because, yeah.
I feel like maybe when you don't fill it up all the way, the air that's left in there does something with the carbon dioxide, and I'm not quite sure what it does yet, but it probably affects it.
Was anybody with the big beakers a little confused how you put the tablet in, but you didn't see water coming out, but somehow the water disappeared? Was anybody else confused with that?
I'm actually pretty sure that's because the carbon in the Alka-Seltzer reacts with the water, creating CO2. So it's not that it's pushing it out, it's literally a chemical reaction creating CO2 from the water in the Alka-Seltzer.
We kind of thought the same thing, because you can really see the water from inside the bin, there's more water in the bin, there's just less water in the graduated cylinder, so we kind of just thought there was some kind of reaction between the Alka-Seltzer and the water, because it kind of looked like the Alka-Seltzer was evaporating the water in some way.
Also going off what my group said earlier, what we said was I think depending on the size of the beaker, I don't know if that's the right word for it, but it lets more out because it's lighter, but also that might not be the case because I tried when we used a big beaker to lift it up while the thing was dissolving, I think, and it didn't make a difference really that much. So I mean, there could be depending on the size, it definitely does make a difference, but that might not be why.
Yeah, it's interesting because we decided we should try with one of the really small beakers because we were getting too small amounts to measure perfectly. And then we tried with the small beaker, we didn't measure all of the gas, and yet it was still 100 milliliters. But when we used a really big beaker, it always seemed to be under 50 milliliters.
That's the same with our group.
Yeah, I think that really don't know quite why. I feel the beakers do make a difference, so we might want to try to have one common size beaker just to get an idea so we can compare it to.
I agree with that, but I feel the reason the beakers might matter is the ratio of the tablet to how much water might be in the beaker.
Well, no matter what, it's always going to release the same amount of gas because one tablet is always going to react the way one tablet would, if that makes any sense. So no matter the amount of water, the one tablet's still going to release the same amount.
Yeah, I agree with that, but at the same time, during some of our trials, like, we got, I don't know if this was due to like some other thing that was happening, but like sometimes we would get like something like one time we got 90, one time we got 70. Like, it's not that big of a difference, but I think that like the tablet does let out like a slightly different amount of gas. Like, it's not all the exact same.
You guys also wanna try to all, like, have similar, or like the same procedures? I don't know, like what Nicola said in the beginning, like, we could all change our procedures. But I feel like in general, like, when we're having these board meetings, it's gonna be a lot easier to like compare data and to like talk to each other about the data if we all did the same thing.
Did anyone actually change their procedure?
No, but I noticed that you guys didn't fill it all the way, which is smart, but like to Greta's point, I don't know, like maybe the air does impact the thing, and if we all do it the same way, then we'll know that the air didn't impact it because there was no air.
Yeah, like sometimes we have like one person doing that, we might find out like if it does make a difference, if everyone else gets like 0.1 and this group has 0.006, then we would know that it does, and that would actually be pretty helpful information.
But then at the end, when people are writing their reports, one group is gonna have like strange data and they'll have to write their report about that. So I feel like we should all maybe do data that would help us like conclude our argument.
Do we wanna like try to decide what that like procedure is?
So like, I don't know if it would be better to do it with the water all the way filled up or not, because if we, like, when we did it without having it all the way filled up, that eliminated like having it spill out when we put it in or things like that. But also like Greta said, I think there might be some kind of unknown factor from the air inside, and I'm not sure what that is, but what do we think is the better option?
Well, I mean, if we can determine what's happening between the carbon dioxide and the air that's already in the graduated cylinder, I think that we could find a better way to do it. But given what we have right now, I think that the most reliable choice would just be to fill up the graduated cylinder to the top with water.
Well, nothing should really be happening because like carbon dioxide, like pretty much what's in there already is what's around us, and then we're just adding carbon dioxide, and nothing happens to the air around us like when we breathe out. So that should mean that nothing's happening here because it's carbon dioxide coming out.
Yeah, it's carbon dioxide coming out, but when we're like measuring the density of the substance, I feel like it's gonna be easier, like, because like in the air right now, it's not only carbon dioxide. Like there's oxygen, hydrogen, like a ton of other stuff. So if we fill the beaker only like 50 milliliters below the top, then like those 50 milliliters are full of things other than like carbon dioxide in addition to things other than carbon dioxide. And you're right, like that might not make a difference if we don't know. But it might be easier for us.
We should just, what we know is to fill all the way up, because then we don't have all these extra factors which we don't really know much about.
Yeah, I agree with that. There's like a reason why the procedure said to fill it all the way to the top, or else it could have said something else, but it said specifically to fill it all the way to the top of the graduated cylinder, so there's maybe a reason why it said that.
I also think we should use a whole tablet, not half a tablet, because like if you're cutting it in half, then you're probably gonna have like pretty major variations between the size, even if like, because I mean, like there are a lot of factors at play, including like how much dust is lost when we break it, as well as it's very difficult to break something perfectly.
We're trying to like use a smaller beaker, so we couldn't use the big one, we couldn't like measure it accurately. And the like full tablet would get stuck in the beaker. We weren't sure, like, we thought that'd be the only way. Cause like I know your team had like a middle size beaker and there's like no other ones.
Yeah, there's like the middle size is kind of like the perfect one for this experiment. It's like has like we had problems with the big one, you guys ended up problems with the big one and the tiny one. So we wanna try to all use the middle-sized beaker and then,
Are there
like,
any of them here?
I mean, the groups that like don't have the beakers, maybe we could like set up, it's like kinda complicated. Like set up rotations, like the groups that don't have the beakers do like the fast.
Yeah.
Groups that do the fast. That might be too complicated though for.
I feel like that would work because our group finished our volume and some people might have just done that, so that would probably be that.
Do the data, change the size of the graduated.
But we had the medium sized one.
You guys good?